See, I'm trying to draw it exactly the same as what I see. So I've got A, I've got 5 over here, B and C. That's my triangle ABC. Now what do you think is another congruent triangle? This time they didn't say, oh, prove that these two triangles are congruent. Now they ask you to name the triangle that's congruent. Obviously there's another triangle on the right side, but the way you name it is very important. Okay? So we may have problems with that. Some of you don't seem to have a problem with that, but for me I have a problem with it. So I will draw out the triangle. I will draw exactly the same triangle over here. Okay, in the same orientation. Okay, do you see that the same orientation? Okay, now I'm going to try and find how it should be labeled. You see that I drew a 1 dash over here and 2 dashes over here to indicate that, hey, actually these two triangles that are supposed to be congruent. Now with this information, I can very easily find what letter this is. What is the letter that we've got these two lines meeting, the 1 dash and the 2 dashes. The 1 dash and 2 dashes over here. Which point is it? C, right? Okay, so we can tell very easily that, oh, this is supposed to be C. Then can you fill in the other two blanks? What is at the top? What is it? E or D? E, okay. And the bottom must be D lah. Okay, so this is what we are trying to prove. I am trying to prove that triangle ABC is congruent to EDC. By drawing it this way, I don't have a fear of writing, ABC congruent to ECD. This will be wrong because of the labeling. Okay? So now that I have my diagram, and I can tell that, hey, actually, you know what? I've already got the length AC equals to EC. Okay, so I can write that down first. AC equals to EC. What is the reason that I can say that they are the same? Yeah, it is given to us. It is shown to us in the diagram already. It's so easy, given. And at the back of our minds, we know that we are comparing a side over here. Okay, then I also know that, yeah, actually I've got another side. Okay, so the other side that we know is that BC equals to DC. Reason given again. Okay, I've got two sides already. Now, we know SSS, SAS, ASA. Given that we have two sides proven to be the same, we should be considering either of these, right? Do I know the length of the third side? Are they the same? How do you know they are the same? Okay, what is the value? 5. Okay, yeah, I know this is 5. Do you know that this is 5? How do you know it's 5? Huh? Both the two lines are what? How do you know they are the same? Where got given? Yeah, but did they say that AB equals to ED? Did they say that? Did they say that? No, they didn't say it. So you cannot use it. However, you are right. Later we will prove that they are the same. But as of now, I cannot prove that they are the same yet. You will definitely not be able to say that AB equals to ED. The number 5 over there was placed to trick you, to see whether you want to use SSS or not. Now you see the 5 cm for AB in the diagram? This 5 over here? It is useless. Okay, you cannot use it. It is a trap. Because they didn't say that this is also 5. Okay, don't fall into that trap, huh? So, what else do we know then? If I can't use SSS, what is my only other option left? SAS, okay? So, we also know that the angle must be an included angle, right? So, which angle must we compare? There's only one that we can compare. Which angle must it be? Okay, what is the name? What is the name? BCA. This angle. We want to prove that this angle is the same as angle ECD. Okay, we want to prove that these two angles are the same. Can we do that? How? How do we prove that these two angles are the same? No, SAS is to prove that the triangles are the same. But right now, you have to prove to me that the angles are the same first. What makes you so sure they are the same? So let's go back to our diagram. These two angles are what we are referring to, right? Right, our ACB, okay, and our ECD. Okay, so these are the two angles. What makes you so sure they are the same? Sorry, Shruvi? Vertically opposite angles. We learned that in Sec 1, isn't it? Did we? They are vertically opposite angles. So we can say that, hey, actually, angle ACB equals to angle ACB ECD. ECD. And the reason, is it given to us? Did they give us this information that they are equal? Did they? They didn't. So how do you know they are equal? That's where you need to write your reason, your Sec 1 work. Vertically opposite angles. So now you've got two sides and you've got an included angle. Which congruency test are we using again? SAS. So by SAS congruency blah 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 triangle ABC congruent to EDC. Okay, so I said before we shouldn't be using this one. Spell it out. Can? Okay, try it. Number 4. I do already. So do you all do it the same way? Is it a case of vertically opposite angles also over here? Okay, try it now with your right angle hypotenuse side congruency test. Only can be used for right angle triangles, but it doesn't mean that when you see right angle triangle you must use this test. Even if it is a right angle, you can use all the other tests if applicable. Okay, so for right angle triangle, we've got a name for the longest side. What is the name for the longest side? Hypotenuse. Everybody can identify that, right? So no matter how I draw my right angle triangle, there will be a longest side. And this longest side is always opposite the 90 degrees. And we call this the hypotenuse. Using the previous congruence cases, the different tests as a reference, right? When we have SSS, we must compare side, side, side. When we have SAS, I must compare side, angle, side with the angle in between. When I have ASA, I must compare angle, side, angle with the side in between. What do you think we must compare for RHS test? You must have one right angle. What else must you have? You must have the hypotenuse. Is it just any side? It must be the hypotenuse. And then the last one? Side. Triangle got how many sides? 3 sides. One side is the hypotenuse. You must use it. Left with 2 sides, right? Any side will do. Okay? These are the rules for this test. Okay, let's see how it works. Example number... Okay, let's look at this one first. I've got 2 triangles over here. I have all the different tests I can use. SSS, SAS, ASA. Now I have RHS. In this case, are they right angle triangles? Yes. So I should consider RHS test. Consider. Never say must use. So do I have a right angle for the R? Yeah, I have both of them right angles. Yes. Do I have same hypotenuse? Yes, it is shown to us, same hypotenuse. Do I have another side that is the same? Yeah, I have over here. Done. They are congruent. Okay? So now example number 6. We've got all this information. Basically prove that this triangle and this one are congruent. For me, I ignore this one. First, I ignore it. Because now I want to prove that PQR is congruent to ZYX. So I draw another triangle on the right side. Exactly the same as PQR, but now I will call it ZYX. This is always my first step. From here, I will fill in the relevant information based on what I've just cancelled off. Okay? Angle Y, it's 90 degrees. YZ is 18. XZ is 39. Sorry, XZ 39 over here. Okay? So I have now redrawn this triangle to look like this. Okay, now I can ignore this triangle again. Ignore it. Can I prove that these 2 triangles are the same? It is a right angle triangle, so consider RHS. See whether I can use or not. So yes, I've got the right angles over here. These 2 angles are the same. I've got my hypotenuse being the same, 39 and 39, the longest side. And I've got one more side that is the same, 18 and 18. Done. Proven. Okay? So, all given, RHS test. So now your turn to try it. Number 6, simple question. Name the pair of congruent triangles. Some of you actually use this as your first triangle. So the next step is to draw exactly the same one. And some still refuse to draw. As long as you can do it, I'm happy. But just don't regret it if you don't build up the habit and then questions get more complex. Okay, so I see a letter D over here for the right angle. Then the shorter side will be DA. So this must be A, and the other one must be B. So I'm going to try and prove that these two triangles are congruent. Right now, I already have one right angle. Put in all other information you have. Okay, I have that this is 65 degrees. I also know that this is 7. Currently, if I compare my two red triangles, I only have one side that is the same. I only have one angle that is the same. It is insufficient information. 2 pieces of information not enough. I need a third one. Either a side that is relevant or another angle. Okay? Can I say that this is 65 degrees? Can I say that this is 65 degrees? Can? Yang Kun can? Cannot. Question didn't say 65 degrees. Can I say that this is X? Can I? Cannot. Question didn't say it is X. So how? I cannot find another angle. What about the side? Which side are the same? B, BD, is it? AB Where got AB? Oh, AB. AB and CD, they are the same, yes. Okay, we've done that already. I need another side. DB and BD, are they the same? Yeah, they are the same line, right? We will write DB equals to BD. DB go DB, okay lah, we will give it to you. So this one, the result will be common side. Okay, is there any way to prove that BC equals to DA? Is there any way to prove that? No, not enough information. Okay, so I've got one common side already, and I've also got DC equals to BA. This is given. And at the back of our minds, this is a special side. What is this side called? Starts with H. Hypotenuse. Okay, I've got a hypotenuse, I've got a side. The only missing thing is a right angle. So angle DBC equals to angle BDA, which is 90 degrees. This one also given. Okay, so by RHS test, triangle blah 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 is congruent to triangle blah blah blah. Can? Okay, then I noticed this interesting diagram at the side. This one. Let's take a look at this one. In the diagram, this is our spot check. AC equals to PR, BC equals to QR, and then they tell you that these two triangles are congruent. Okay, what test shall we use for this? Think about it. What test should we use? I give you option, RHS, SAS. Why SAS?
Because there's no hypotenuse and it's like one.
Okay, I've got the angle, which happens to be 90 degrees, in between the two sides. Do I have the hypotenuse? Did they give you hypotenuse? No, so you cannot use RHS test. Cannot use RHS because hypotenuse not given. Okay, so this is an example of what I was saying. When you see right angle triangle, doesn't mean you must use RHS test. In this case, you'll be using SAS. Questions? Hey. Oh, is that all already? Yeah, that's all already. Shall we do some homework questions? Okay, so homework 3.1.